Hey guys, welcome to today's lesson. Today we're looking at the elimination method of simultaneous equations. Now last lesson we learned how to do the substitution version. We learned what a simultaneous equation was, but today we're now going to look at the setup and how we go through elimination. Now substitution, you could do substitution with any of these questions, absolutely. For example, we look at question 1, we could rearrange the top one and make this, let's say for example, we could say this is y equals minus x plus 8 or 8 minus x. And then we could then substitute that value into the second equation. We could do that. But sometimes when it's set up really nicely like this, we might choose the elimination method. Now, you might say, well, what's setting up nicely? Have a look at the vertical kind of columns here, and you'll notice that we have the same variables underneath each other and the same numbers with the equal sign underneath each other there. And this is set up quite nicely for another method. Now you may have done this before, I'm hoping you have, but if you haven't, we'll go through it obviously. Now, we've got two options here when we're looking at elimination. Elimination means to get rid of. We're going to either add these two equations together or we're going to subtract these two equations together, and hopefully one of those will result in one of the variables disappearing. Now, let's say for example, we call this equation 1, this equation 2, and I add them. That means I'm going to basically plus the two equations together. I'm going to plus the two left-hand sides together, plus the two right-hand sides together, and then see where that takes me. That means, for example, on the left-hand side of the equal sign, so if I add the x and the 2x, that would make 3x. If I add the y's, that makes 2y. On the right-hand side, if I add those together, we get 13 plus 8, which makes 21. And there we go. Now, unfortunately, there's an issue here. This is called the elimination method, and the whole idea is that we are eliminating one of the variables. We haven't done that in this situation, so addition has not worked for us. So let me just go back and see what if we subtract them. Exact same method, right? Instead of adding the two variables or two left-hand sides and right-hand sides together, we're going to subtract them. Now, of course, when we're subtracting, different orders, it can matter with what the value looks like, but in this case, it doesn't really make much of an effect. So for example, I could say x minus 2x equals minus x. Thing is, I try and avoid negative values if I can. I'm going to start with the bottom line. In fact, I am going to write here, second equation, subtract the first equation. So what's 2x minus 1x? Well, 2x minus 1x is just x. What is y subtract y? Well, that's 0, right? And what's 13 subtract 8? Well, that's going to be 5. And what we've actually got there, straight away with one swift movement, we've now got a result or a solution to our equation. X is equal to 5. Now, hopefully remember too that this is simultaneous, which means there are two variables, two solutions, two answers. I'm going to choose the top one. Looks a bit easier. Okay, we've got X, so which is 5 plus Y equals 8. I'm now going to take the y across the other side. 8 minus 5 is 3, and I now have my two solutions of 5 and 3. Perfect. I could have done it the other way and said minus, so x minus 2x is minus x, 8 minus 13 is going to be minus 8, or whatever it's going to be, and then I'm going to subtract across, and I'm still going to get the same answer. That is why elimination works quite nicely. Okay, but they have to be kind of aligned, and you've got to try and eliminate. And sometimes you've got to go through that process. Do I either add them or do I subtract them? You've got to be careful when you do see negatives there. Now, this second equation, again, in order to know something's going to eliminate, we're going to have the same amount of x's or the same amount of y's. Now, in that second equation, you can see here that the x's don't have the same amount of them like that previous question. Which means if I add the x's or subtract the x's, they're not going to disappear, right? That's okay, because if I look at the y's, we have one of each. Now, what are we going to do in this question? Are we going to add them or are we going to subtract them? Well, if I subtracted them like that previous question, minus y, that makes minus 2y. Or if I start with the bottom equation first, let's call it the second equation, y subtract negative y is positive 2y. They haven't eliminated. So in this case, subtraction doesn't actually work. So what I'm going to try and do is I'm going to just try and add them together. Now, x plus 2x makes 3x. Negative y plus positive y, Well, that makes 0, right? Disappears. 9 plus 21, well, that makes 30, which means x equals 10. Simples, right? Now I'm going to look at the equations. I'm going to use the first equation because, it looks a bit easier. I'm going to sub that in. 10 minus y equals 9. I'm going to subtract the 10 across. Minus y equals minus 1. I'm going to move the negative across. Y equals positive 1. I now have my two solutions, 10, 1 as an ordinate or a coordinate. There you go. Simples, right? Obviously, you get harder questions, and we've got a couple harder questions that we're going to look at. You might want to pause this again, gents, and have a crack at these questions if you would like, or you can just run with me if you feel up to it. Okay, so the third one, I wonder whether you see whether this is a harder question. It actually isn't that harder, is it? We got 2x plus y equals 8 and x plus y equals 5. Not really much difference, to be honest. You should be able to do this on yourself. Let's call this equation 1 and equation 2. Am I going to add or subtract? Well, hopefully you said subtract, because if I add them, I get 3x and 2y. Doesn't eliminate. So we're going to subtract them. We're going to do first equation minus the second equation. 2 minus 1 is 1x. Y minus y disappears. 8 minus 5 makes 3. Simple question, right? Tuck it back into the second equation, looks the easiest. 3 plus y equals 5. Y equals 5 minus 3 is 2. I have my two solutions, 3, 2, just as easy. All right, nothing really different there. Okay, hopefully the next question is going to be more challenging. Yeah, definitely more challenging. Both of these are harder questions. So what makes question 4 more challenging than those last 3 questions? Now, if I try to use substitution, these are doozies, right? Because if I had to use substitution here, I'm going to be doing something like this, right? 2x equals 20 minus 3y, then x equals 20 minus 3y all over 2. I'm going to then take that, I'm going to plot it where the x is. That doesn't look nice. So you can see why substitution really shouldn't be used except if you have an equation that says y is equal to. Otherwise, elimination works really nicely. Now, there's another issue here. If I add these together, I get 5x and 7y, hasn't eliminated. If I subtract them, let's start from the bottom this time. 3 minus 2 is 1x, 4 minus 3y is 1y. Well, I've added and subtracted, yet they haven't eliminated. So is this not a correct question? Well, it is. In order for us to be able to eliminate, I said previously that the x's or the y's have to have the same number in front, right? It's the only way when I subtract or add them, they're going to disappear. So what I can do is modify some of these equations. Let's call this equation 1 and equation 2 in order to make the x's the same or make the y's the same. Let's use the x's, right? Let's look at the 2 and the 3. What do 2 and 3 both go into? Well, hopefully you recognize they go into 6. So let's multiply the first whole equation by 3. So if I do that, I'm going to times every single thing here by 3. 2 3s are 6x. 3 3s are 9y. 20 times 3 is 60. I'm going to call that equation 3. It's the same equation. I just have multiplied by the same number and made an equivalent equation with a different value there. Likewise, for the bottom equation, 3x times 2 makes 6x. I'm going to times the whole bottom by 2. So I'm going to do 3x times 2 is 6x. They're the same. 4 times 2 is 8y. And 27 times 2 is 54. I'm going to call that equation 4. You don't really need to write equation 1, 2, 3, 4. I just do that when I'm teaching it because sometimes it's a little bit easier to understand. Now, when I look at that, see how if I add them, they still don't eliminate. But if I subtract 6x and 6x, that makes 0. They now eliminate. Now, I'm going to use the third equation, subtract the fourth equation, just so I have a positive number. So x minus x is 0. 9y minus 8y, well, that's just going to be 1y. And 60 subtract 54, well, that's 6. Look at that. By doing that kind of equivalent equations, I've now got a really nice solution of y equals 6. Now you have an option of 4 different equations which you can sub that y equals 6 into. To be honest, there's no real equation there that's the easiest, so I'm just going to choose number 1. I'm going to say, first equation is 2x plus 3 lots of y, well 3 6s are 18, equals 20. I'm going to subtract the 18 across to make it 2x equals 2. I'm going to get x equals 1, and I now have a really nice solution of 1, 6, okay, or x equals 1 and y equals 6. I hope that made sense, and hopefully you had a crack at that question as well. Now, I thought I'd do question 5 because question 5, again, is a bit more challenging, except I shouldn't have used b. Okay, that is a b. It's not a 6. And that makes it strange, right? Because now you have 3 unknowns. However, in this type of equation, you'll be told that b is a constant number. Okay, now you won't be able to find what that constant number is going to be, but you'll find an expression. And I think it's later on in your exercise that you'll be doing later on today. We're going to start the same way. Okay, do I have the same amount of variables that maybe add or subtract to make 0? And we do, because we have a minus by and a plus by, so I have the same amount. If I add them together, a negative and a positive will disappear. So I'm going to call that equation 1, equation 2, and we're going to simply add those two equations together. X plus 2x makes 3x, minus by plus by, 0 disappears. 4 plus 9 makes 13. If I divide it across, we get a really nice simple solution of 13 on 3. Not a very nice solution, but it is a good solution. And now all I'm going to do is choose one of the two equations to sub back into. I might choose a second equation this time, only because we have a positive by. So I'm going to have 2 lots of 13 on 3 plus by equals 9. 2 times 13, of course, is going to be 26 on 3 plus by equals 9. I'm going to subtract the 26 on 3 across. Okay. And then from that, so that's going to be by equals 9. Now, we should be able to do this without the use of a calculator most likely, but I'm going to do this really fast. So we've got 9 subtract 26 over 3. Now you can use decimals if you want. It's over 3, so it might not be very nice, of course. That's 1/3. And now, of course, we want y equals, so I'm going to then divide it by the 3. So I get 1 over 3b. And that's my second solution. So therefore, we have 13 over 3, 1 over 3b, and my job is done. And that's a really challenging question, but you can see the methods are exactly the same. Look, that is elimination. You now have 2 methods that you can use, either substitution or elimination. Remember, just as a bit of a summary, if you have something like this, x plus 3 equals 7, x plus y equals 7, and y equals 7x, versus x plus y equals 7, x minus y equals 8, let's say, for example, this first method would work well with substitution because you have the variable equals something, okay? Whereas the second example would be more like elimination because they're nice underneath each other and we can go either adding or subtracting. Of course, if you really wanted to, you could take one of these, for example, the second equation, and make it x equals y plus 8, rearrange it, and then do substitution. But I would really like you to start using the elimination method so you're getting used to it, because later on we get those harder questions like the last 2, it makes it much easier. Gents, have a crack at the questions. Likewise, every single session, Canvas, message me if you need some assistance, or your teacher, of course. Otherwise, have a wonderful day and good luck with the questions.